1, 2, 2, 3, 4. Hey!
Our goal in this project is to create a very simple model of the Apollo trajectory. The graph shows the result of the project. The trajectory of a rocket launched from Earth that flies up to the moon and with a little nudge goes into orbit around the moon. The graph shows the entire flight, including 5 orbits around the moon. We start with our program to shoot the moon. That trajectory is shown here. And we reduce the launch velocity till the rocket just misses the moon on the trailing edge as shown in the graph. As seen from the moon, and ignoring the effects of Earth gravity, which is nearly constant, the rocket is in free fall. And since it is coming from outside the moon's gravitational reach, it is not in orbit, so it must be following a parabolic or hyperbolic trajectory. So, it's not going to go into orbit around the moon without some help. So we'll give it some help by giving it a little nudge just as it passes by the moon. In a more detailed model, we would model the rocket's orientation and thrust angle and resolve the thrust direction into x and y coordinates. But our rocket doesn't have an orientation. We're treating it as a point mass, and we are striving for simplicity. We do model airplane and rocket orientation in a later project. So for now, we just give it a thrust translated into acceleration and expressed directly in x and y coordinates. In particular, we give the rocket a timed acceleration boost in the -y direction just as it passes the moon. The code is shown. The parameters for the guidance boost are the boost acceleration, y boost, and the boost duration, b time limit. The variable b timer times the duration of the boost. The boost begins just as the rocket reaches the altitude of the moon's center of mass. So we select a time limit and a boost value and give it a shot. We can see from the top graph that we gave it too little, too late, and the rocket didn't go into orbit. In the second graph, we increase the boost value, and if you look closely, you can see that the rocket hits the moon as it tries to pass in front of the moon on its first orbit. So we need to reduce the boost a little. We do that, and the results look promising. So we increase the flight time. It still looks good. So we let it fly, and we have a winner. The bottom graph shows the complete trajectory from start to finish. The assignment is to get the Apollo sim running. All that is needed, starting with the Shoot the Moon sim from the previous video, is to slow down the launch velocity so that the rocket just misses the moon, then to insert the code for the guidance boost shown here and adjust the parameters so that the rocket goes into orbit around the moon.
Every day I have the blues. Every day I have the blues. When you see me worrying, honey, you know it's you I hate to lose. Said every day, each and